Assalamu alaikum. I am Abida and I'm going to teach you Analytical Chemistry 2 Chem 508. This course is prescribed for BS Chemistry 6th semester session 2017 to 21. So today we are going to discuss properties of light and its interaction with matter. Light consists of electromagnetic radiation, that is, it has an electric part and magnetic part. Here, electric part of light radiation is represented by blue wave, while magnetic part is represented by red wave. So these electric and magnetic fields, they are perpendicular to each other, as you can see in this picture. They are not only perpendicular to each other, but they are also perpendicular to direction of propagation. By means of direction of propagation, I want to say that the direction in which light travels. So electromagnetic radiation have different properties, and one of the important properties is wavelength. Wavelength is represented by letter lambda, and this wavelength is the distance between two adjacent troughs, or it is the distance between two adjacent crests. The more about properties of electromagnetic radiation and their relationship. So we have just discussed wavelength lambda, which is represented by this Greek symbol, and its units are centimeter or meter. So the units used for wavelength depend upon the electromagnetic region we study. For example, in case of UV, that is ultraviolet and visible region, the wavelength used is nanometer. Okay, the relationship of wavelength with speed of light and frequency, this can be mathematically represented as lambda is equal to c divided by nu, where c is the speed of light, which has a numerical value of 3 into 10 raised to power 8 meter per second, while nu is the frequency. Frequency is the number of waves passing through a point per unit time, and it has units of either second inverse or hertz. Nu has a mathematical relationship with lambda, that is nu is equal to c over lambda. Then the third property by which we can represent electromagnetic radiation is wave number, and this is represented by nu bar. It has a units of centimeter inverse, and it is the number of waves passing through a unit distance, and mathematically it can be represented as nu is equal to 1 over lambda, or it can also be written as, if we put the value of 1 over lambda, then nu bar, this will be equal to nu over c. Each electromagnetic radiation is also associated with energy, which is represented by symbol E, and for 1 photon of radiation, the units of energy are ergs. Energy can be represented mathematically as E is equal to h nu, where h is Planck's constant, and if we put the value of nu here as nu is equal to c over lambda, so this equation will become E is equal to hc over lambda. Okay, so I will actually give you some other presentations I will give you through WhatsApp, so you can very best understand the concept of wavelength, frequency and wave number through these slides. So this will come after. First you will have this presentation, and after that you will have 3 or more presentation on the topic of wavelength, frequency, wave number and energy, and then you will be able to understand very well about these concepts, inshallah. So now we have electromagnetic spectrum. Actually the wavelengths of radiations which reach from sun on earth, they consist of different parts. right? So this electromagnetic spectrum can be divided into different parts depending upon the wavelength of these regions. So we will start from gamma rays and X-rays. These are highly energetic waves. So as we have seen in the previous slide, energy, frequency, energy or frequency and wavelength, they are inversely proportional. It means that if an electromagnetic radiation has shorter wavelength, it must have high energy or high frequency. So gamma rays and X-rays, they lie in the shorter wavelength end of the electromagnetic spectrum. So they are of shorter wavelength and highly energetic waves. They are important for medical diagnosis, but for analytical purposes they are not in so much use. For analytical purposes, we are mostly concerned with the next region of electromagnetic spectrum, that is ultraviolet and visible region. So ultraviolet is further divided into two regions, that is vacuum ultraviolet and near ultraviolet. We say it as near ultraviolet because you can see that it is near to the visible region. So the ultraviolet region, it extends from 10 nanometer to 380 nanometer, but for analytical purposes the important region is from 200 nanometer to 380 nanometer, that is near ultraviolet region. Below 200 nanometer, the air absorbs appreciably, so we have to operate it under vacuum, which is not so easy to attain. That is why for analytical purposes the important region is from 200 to 380 nanometer. And then we have the visible region which extends from 380 nanometer to 780 nanometer. And after that we have infrared region. Infrared is again divided into near infrared, NaCl infrared or mid infrared and far infrared based on its distance from visible region. So infrared region, it extends from 0.78 micrometer to 16 micrometer. But for analytical purposes, the important region is from 2.5 nanometer to 2.5 micrometer to 16 micrometer. So if we take this in centimeter inverse, actually this unit is used for infrared region most commonly or arbitrarily. So if we use a centimeter inverse, then for analytical purposes that is from 2.5 micrometer to 15 micrometer, which is most commonly used infrared region for analytical purposes. If we take this region in units of centimeter inverse, then this will be from 4000 centimeter inverse to 667 centimeter inverse. So we use this for analytical purposes. So keep this in mind that infrared region is used or infrared radiations, these are used for the determination of functional groups in organic compounds. And after that we have radio wave. Radio waves are at the higher wavelength end of the electromagnetic spectrum, so they have the lowest energy. How does matter absorbs radiation? Objects will absorb certain wavelength, leaving the certain of the wavelength as transmitted, which we see as a color. This is called complementary of the absorbed color. So what will happen actually, the objects, they will absorb some of the wavelength. For example, white light, it consists of 7 colors and it has a wavelength range from 380 nanometer to 780 nanometer. So if the wavelength absorbed by an object is from 380 to 450 nanometer, it means that the object will absorb violet color and the remaining light which will be transmitted, they will be of the wavelength having color yellow green. So this yellow green, actually this is called the complementary color or the transmitted color of the absorbed color. Likewise, if we have, for example, a substance which will for which the absorbed wavelength is 450 to 495, then actually it will absorb blue light and it will transmit yellow light, so it will appear yellow to the human eye. Likewise, if the absorbed color is yellow, then the transmitted or complementary color is blue. And for orange absorbed color, the complementary color is green blue, and for red it is blue green. So this is how electromagnetic radiation are absorbed by matter, and the color which we see of the objects, they are of the transmitted or the. Then interaction of electromagnetic radiation with matter. Actually, now we are going to see what will happen, or what is the analytical usage of these electromagnetic radiation with matter. So what will happen actually in spectroscopic methods, the sample solution absorbs electromagnetic radiation from an appropriate source, and the amount absorbed is related to the concentration of analyte in the solution. So if we have a solution containing copper ion, this will be of blue color because it will absorb complementary color yellow from the white light and transmits the remaining blue light. So more concentrated the copper solution, the more yellow light is absorbed, and deeper the resulting blue color of the solution. So what will happen in spectroscopic method, the amount of this yellow light absorbed would be measured and related to the concentration. In this way we can obtain a better understanding of absorption spectroscopy or absorption spectrometry. So in the next lecture we will actually start again from interaction of electromagnetic radiation with matter, and we will see how electromagnetic radiation they interact with molecules, and after their interaction what kind of motions are occurring within the molecule, that is translational, rotational and vibrational. So I will send you this lecture, and along with this I will also send you 2 or 3 more presentations in order to have a better understanding of these topics, inshallah. Okay students, good luck for this, and we will inshallah meet soon with the next presentation. Allah Hafiz.